the activity series and single replacement reactions. This is kind of an addendum to chapter 4, so this is adding to what we've already talked about with chemical reactions. So a single replacement reaction is a little different than what we saw with the double displacement or replacement reactions that we saw with precipitation reactions. Typically, a precipitation reaction is a special kind of double displacement. A single replacement reaction is a little bit different, and typically we associate a lot of redox chemistry with single replacement reactions as well. So it takes on the form of this general equation we have here. So M is standing for a metal, typically some sort of metal. And then Bx can either be like an acid or some other complex that when these two are added together, depending on how reactive this metal is in comparison to the other material, sometimes what will happen is the metal will replace the other cation that was in the material. So here we have an example with zinc and HCl. And so zinc is a solid, so it's individually by itself, which means that the oxidation number for the zinc right now is 0 because it's elementally pure by itself. And then we're adding to it HCl. And we're going to learn how we know that the zinc is strong enough and active enough to replace the hydrogen and become zinc chloride and produce hydrogen gas. As we go through this, right, you can go through and identify all the oxidation numbers. We know that the hydrogen, right, in the HCl is being reduced to 0 because this is hydrogen gas, so this is elementally going to be an oxidation number of 0, so we went from +1 to 0, and the zinc went from a 0 to a +2. And then here's our net ionic equation for that as well. We can also have this occur with a metal salt, or a metal and a salt. So we can have a metal and an acid, or we could have a metal and a salt. Here again we have zinc, and in this case the other salt is another metal, right? So the cation comes from a metal, in this case copper, with nitrate. And again we see that we have this kind of switching of partners. The zinc steals the nitrate from the copper, and so the zinc was by himself at the beginning and the copper is by himself at the end. And again you can go through and identify the oxidation numbers and who is reduced and who is oxidized, who's the reducing agent, who's the oxidizing agent. And then when we look at the net ionic equation here, I want to ask you what happened to the nitrates. Hopefully you realize that this compound right here, copper nitrate, copper 2 nitrate, the way it's written, aqueous, that's our secret language. I know that you know that this is Cu plus 2 and NO3 minus 1. And then we still have it over here as well, that this is really Zn plus 2 and NO3 minus 1. So NO3 minus 1, we have 2 of them on the reactant side, 2 on the product side. Those are our spectator ions, so they go away in our net ionic equation. So how do we know if a single displacement reaction is going to occur? How do we know that the zinc is going to replace the copper? Or how do we know that the zinc is going to replace the hydrogen? How can we predict this? So for this we will have what we call an activity series. I have posted a file into the module. I strongly encourage you to print it out. This would be a good resource for you to have for tests and quizzes. You don't need to memorize it, but you should be able to read it. So you should be able to look at it and read it and know exactly what you need to do with it. This is also a good place for you to take some notes on things. So it lists a lot of metals and hydrogen in order to give an idea to predict who will most likely oxidize first, right? Or give up electrons. We know that oxidation is the loss of electrons, right? If one metal is above another in the series, it will tend to lose electrons and become an ion. Metals listed above hydrogen will react with the acid to form H2. Those below it will not. So going by that example, we have here the zinc must be above hydrogen in our activity series because it reacts and produces hydrogen gas. So let's look at the activity series. Here is a version of it. I have a higher resolution version for you in the module that isn't as grainy. And so here again, right, we have hydrogen down here. Oh, look, and here's zinc. Zinc is above hydrogen. That's why the zinc was able to replace the hydrogen when we had the two together with HCl. So here I'm just giving you a quick example. Copper is above, copper is above silver. So here's copper and here's silver. So copper can replace silver, but copper cannot replace zinc. So do we see how in this situation the copper was by itself, and here was the silver complex as a salt, and the copper was able to replace it, kicking out the silver, so now the silver is by itself because the copper is above the silver. However, if we're looking at copper and zinc, copper's here, zinc is up here. Copper is not reactive enough to replace the zinc, so there's no reaction. So this is how we're able to predict when we are given reactants whether a reaction will occur or not. So I'd like you to go through and try these on your own. I have 3 different examples of some reactions here. I would encourage you to write the reactions, so go through. Do the molecular, the complete ionic, and the net ionic equation for each of these, and then determine whether which one of these is a single replacement reaction. This will be very good practice for you. You could also go through and determine oxidation numbers and oxidation redox type stuff. So you could go through and determine who is reduced, who is oxidized, who's the reducing agent, who is the oxidizing agent. I have posted a page in this module that goes through this, but I strongly encourage you to try this out on your own first. To make sure that you understand the concepts that are being asked. As always, if you have any questions, please let me know.